Today we're going to be talking about set theory. We're going to be going over the basics of set theory today. It's a very important topic in mathematics, logic, and almost every industry and career you can think of probably will benefit from you knowing set theory. So, set theory used to be taught in middle school, and they eliminated it from the middle school curriculum in favor of just pure algebra now these days, which is kind of unfortunate. So most people don't get set theory until college now, but just be aware that the concepts are not really supposed to be that hard, and they're a middle schooler could do it. So let's get into it. So what is a set? A set is just a collection of things, and for everything in the world, either that thing is in the set or it's on the set. So for example, and you can almost make a set any way you want. There's like a small caveat to that, but basically, if you can say it, you can make it. So if I said set A is the set of all people in my house right now, then I am in the set, and this Easter egg is not. Okay? This, I don't know what this is, remote control of some sort is not in the set of all people in my house. My wife is in my house right now, so yeah, she's in the set. You guys understand? And so basically, that's all a set is, and you can define it however you want. A lot of times we do it in math. We say the set of all even numbers, the set of all odd numbers. Does that make sense to you? You can kind of define them however you want. The set of all cars made by Chevrolet in 1980 is a set, and things are either in the set. I am not in the set of all cars made by Chevy in 1980 or 1981. I guess it says on the slide. All students in class right now. The set of all students in my class is 90 some odd people. The set of all students who are watching the stream live right now is 13. Size of the set is 13. Does that make sense? So, and there's different ways you can talk about those sets, right? So the set of people in the class is a big set. The set of people in the class who are watching my stream right now is a subset of that bigger set. And we'll get through the terminology in a little bit, but basically there's different relationships sets can have with each other. The set of all even numbers and the set of all odd numbers are disjoint sets. They don't overlap at all. There's different words that we use. There's a lot of terminology in set theory, but the basic concepts are pretty easy, and the terminology that you use from it, like that's a subset, are used everywhere. Like you go into engineering, right? And you've got to, I don't know, you're working for Boeing, let's say, and you come up with a fix for the 737 Max plowing itself into the ground. They'll say like, all right, what subset of 737 Maxes will this work on, right? That terminology is just part of most professional practice. It's used in math and engineering and law, and just in any sort of technical sense, you will see the terminology that you learned today used in a lot of professional contexts. So the basic ideas aren't hard. Like everything in math, for some reason the math community makes things harder by using weird symbols for stuff. So that's really the challenge. Conceptually, these things aren't hard to understand at all. It's either in the set or it's on the set. A smaller set from a bigger set is called a set. Like conceptually, they're not hard, but there's all these like bars and hats and all these things they do in math just to, I don't know, just make it hard for you guys to learn. I'm sorry. Okay. So I write sets using curly braces like this. Okay. And members in a set are called elements. Elements. Everybody type into chat element. Element is a member of a set. Okay. Where did they stop teaching set theory in 6th grade? It's a good question. There is a big restructuring of American education. I think there's been twice since I was in middle school, And I think in the first one, I don't think it was Common Core that dropped it. I think it was the first big one since I was in middle school that dropped it just to focus almost entirely on algebra. Element. Good. Terminology. There it is. So elements are members of a set. All right. And so here are elements of the set of all cars made by Chevrolet in 1981. So the 1981 Chevrolet Citation is a member of that set, the set of all cars made by Chevy in 1981. This was, in fact, my first car, and it is a terrible car. It really is. It's quite ugly, and there's just nothing good that you can really say about it. I mean, it's named after a parking ticket. Like, what do you expect? Like, you've got the Tundra and the Explorer and the Tacoma. Like, you got all these like cool names for cars and trucks and stuff, and this one's named after literally a parking ticket. So I don't know. Engine swap time, yeah. I do know some people would do that to the Citations, and like they're playing Gran Turismo or something, right? Here is the 81 Chevy Camaro. The Camaro was kind of the Chevrolet's response to the Mustang, right? And some Camaros can actually be quite powerful. From what I understand, some of them at the time didn't have a rigid enough frame, and they would actually bend their frame. I don't know if it was this year though, but I had a friend who drove a Camaro, and he said that like the frames bending was like a problem on them. I don't know. I'm not really a car guy. Okay, so this is an element of the set of all cars made by Chevrolet as well. Okay. 81 Camaro is downright ugly. Yeah, I'm not. It looks like somebody doing this, right? Like, look at that. Like, that looks like teeth there and two eyes and a nose. I don't know. I think the older Camaros were actually better looking. Let's see. Yeah, and then they have the new ones are actually pretty good, actually. I think they had some pretty good lap times. The old... When did it come out? It was like 1960 something. Yeah. The original Camaro. I think that's actually better looking than the 1980 version. Like that's kind of a cool looking car. It's kind of reminiscent of the Mustang, I think, and maybe deliberately so. I don't like that color though. But yeah, that's a cool car. Chevy K9. That's a good one. Yeah, I don't know what happened. It's like, the modern Camaros, like I think they look pretty good, and the classics look pretty good, but I don't know. The 80s were a weird time. I don't know what to tell you. Okay, so we typically use capital letters to represent sets. Capital A, A is a set of all even numbers in Z. Z is what mathematicians call the set of integers. I don't know why they pick Z instead of I. I guess I is already used for imaginary numbers or something. I don't know. So, like I said, the hardest thing about set theory is just the terminology, and you got all this like, what's going on here? And yeah, just remember everything in the universe. It's just either in the set or not in the set. So this is B is defined as all x such that x is an element of Z of integers where x is greater than 42. So in plain English, we're just saying make a set of all the integers bigger than 42. That's, you can say it in English and it's understandable, or you can write it in set builder notation like this, where people are like, it's actually a pet peeve of mine. Like I feel like, jargon has a place and terminology has a place, but like when you sort of make your stuff hard to understand for students, like it kind of bugs me. Like I'm always looking out for you guys, And then you can also just make a set out of like whatever. So again, we use curly braces to represent sets, And so C is equal to 4 and 6.2 and 11 times the imaginary number I, negative 52, and Bob. You know, like you just make sets like however you want. Like there's no, you know, there's really not many rules governing it. I think the only rule that people care about is that it can't be contradictory, you know? So you can't have both Bob and not Bob in the set. I don't know. All right, so this is the thing, this is the thing that always gets people. So pay attention. Come back to me after talking about the Camaro. All right. You all know absolute value bars, right? Like vertical lines. You put a -5 in there, it turns into +5. You know what I'm talking about? Yeah, yeah. So this is not absolute value, and this is something that gets students every year. And I put it on quizzes over and over again, and they always get it wrong because they think they know that, you know, the absolute value of -5. That's a horrible vertical slash. There we go. The absolute value of -5 is 5, right? Wrong. This is nothing to do at all with these vertical bars here, because why make something sensible when you can do symbols that confuse the hell out of people? I don't know. The vertical bars for set theory is the size of the set. So the size of C is 5 because you got 1, 2, 3, 4, 5 elements. Okay? Put it on quizzes constantly, and you can tell which students have not seen the quiz based on the fact that they're like, I don't know how to take the absolute value of this. No, it's not absolute value. It is the size of the set, and they could have done something like this. They could have like just said size of C, you know, like just spell it out, you know. I don't know. But they don't. They use absolute value bars to mean something completely different from absolute value, and it irks me. It irks me moderately. Because it makes it hard for students to learn, and students get it wrong all the time. You know, so here's a question. What is the size of A? Right? So A is all of the even numbers, all even integers. Whole integers are whole numbers, right? 5 and 6 and -20 and 0 are integers. What is the size of all even numbers? How many even numbers are there? Most sensible people would use size. Yeah, math terminology is like one of those things. It's like, it's fine to use it after you know what you're talking about. You know what I mean? To like make things compact and not too verbose. You know, and it was invented at a time when we didn't have computers. You know, so like, you know, doing things like a little curly S or whatever. You know, like I kind of get it, but like I don't know, it irks me. I'm always looking out for you guys. So infinite, yeah. So it's an infinite size. Yeah. What is the size of B, for that matter? What is the size of B? And on quizzes, if I ask you to type in like the size of an infinite set, I usually put a note saying like type in -1 or something. It doesn't mean the size of an infinite set is -1. There's no such thing as a negative size. It's just it works for Canvas, you know, because Canvas has a quiz option where it only takes numbers, right? And so infinity is not a number. So I just say, you know, put in -1 or whatever, just so we can give an answer for infinity. What is the size of B? B is all integers greater than 42. What's the size of B? What do you guys think? How many whole numbers are there larger than 42? Isn't it still infinity? All values greater than 42? Yeah. So what is the size? What is the size of that set? How many integers are there greater than 42? That's what I'm asking when I put the vertical bars there. Okay. And yeah, Eric, you a lot. Yeah, Eric, you're right. It's also infinite. It is another infinite set. So one way that you can count the size of a set is if you can come up with a 1-to-1 non-2 correspondence between two sets, then they have the same number of items in them, right? So if you have, if you know that you have 5 leopards and you can draw a line between every leopard and every sheep, then you know that you have 5 sheep without needing to count it. It's kind of a cool little fact. Right? You don't need to worry about that. Okay, let's do more terminology. So the complement to a set is written with a little exponent c. And again, this is a place where people look at that and they say, oh, I know what that means. That's exponentiation. And again, you're wrong. Not because it's your fault, but because math people are like, all right, well, we've already screwed up the terminology for absolute value. Let's screw up the terminology for exponent, right? It doesn't mean exponentiation at all. It doesn't have anything to do with exponentiation. None in the slightest. Not at all. So if you have, for example, what was it? If we have E is all even numbers, then the complement is all odd numbers. Okay? So complement means everything in the universe not in our set. Okay? It's a not operation. And we have lots of terminology for not. You could say not E. You could say not E. You can say not E. There's a lot of things we use to represent not in logic and math and things like that. And they chose to not use any of that and instead use exponentiation to indicate things not in the set. So, like I said, the terminology is the hardest part of this. It's not conceptually hard. So if the universe, let's say the universe is the numbers from 1 to 10. That's all that exists in the entire universe, just the whole numbers from 1 to 10. And we've got a set A that is 1, 2, and 3. What is the complement of A? So the universe, the only thing that exists in the entire universe are the numbers from 1 to 10. A is the first 3 numbers. What is the complement of A? It's not exponentiation, remember. It's the complement. It's a set of all things that are not in A. 4 through 7. Interesting. So you're saying 8? Is my handwriting bad? That's a 2. 1, 2, and 3 are in A. So the complement through 9? Yeah, 9 is in AC, but what is the complement of A? It's going to be a set, right? So you should write it in set form, right? So 4 is in it, right? 5 is in it. 6 is in it. 7, 8, 9, 10. Or if you want to not waste your handwriting, 4 dot dot 10. Shortcut. Okay. It is not infinite. Yeah, it is. The entire universe is just 10 numbers. 3 of them are in the A. So 7 of them are in A complement. But I didn't ask you for the size. If I'd ask you what is the size of A complement, which is a very common quiz and final question, mind you, what is this? What is the size of A complement? How many elements are in the complement of A? And again, to somebody who hasn't had this lecture, they're like, I'm taking the absolute value of the exponentiation. No, you're not. Don't do that. Don't do that. Watch the lectures. It's a very low threshold for a college class. You just watch the lectures, learn the stuff, take the quizzes, get A's. You know, this class really is not designed to be a murderous class. 7, very good. Yeah, so there's 7 elements in the complement, right? 1, 2, 3, 4, 5, 6, 7. Okay. All right. So if the universe is the numbers from 0 to 5, the complement of A, which is 0 to 3, is 4 and 5. All right. Now sometimes you know, the complement might be nothing, right? Like if I had A, B, A, B. If A was 1 to 10, what is the complement? How many elements are not in A? If the universe is 1 to 10, A is 1 to 10, how many people are in the complement? 0, right? And so we have another bit of terminology here called null. Null is not the number 0, right? Because 0 could be an element of a set, right? Like right here you can see 0s in the set. Null means it is empty. There is nothing in the set. I personally would prefer writing it like this. There's nothing in it, right? But mathematicians made a special Nordic 0 or something. I don't know what the technical term is. And that means there's nothing in the set. It looks like there's something in the set because there's something between the curly braces, but there's not. There's nothing in the set. That means the set is empty. Okay? And so the size of the empty set is what? That's a good quiz question as well. Got 3 bits of terminology there. The absolute value bars, which don't mean absolute value, the curly braces, which indicate that you're talking about a set, and the null character, which indicates the set is empty. So what is the size of the empty set? The size of the empty set is 0. It looks like there's something in there, but there's not. The Nordic 0 means there is nothing in the set. Like I said, I would have preferred this. This is better. But they like coming up with weird terminology. So they're like, we'll make a 0, but so that people know it's not 0, we'll put a slash through it. There you go. Yep. So the size of the empty set is 0. There is nothing in the empty set, the null set. Yep. Okay. So, yeah, like I said, conceptually it's not hard. All right. What is the set on chat? What is the set of all the apples that I have in my hand? I want you to list all of the apples I'm holding in my hand right now. Not 0. You use set notation. It's 0 the slash. Nil. Yeah, nil is another way that you could write that. Sure. Open close curly braces is how I would prefer writing it, but the maybe you realize you don't have a null character on your keyboard. Yeah, that's some of the fun of set theory, is that you actually don't have keys for that. So if you guys want to figure out how you can type that on Discord, right? Let me show you my this is how I make my quizzes. Null character. All right, and then we scroll around on here, and no, that's actually C++ is null character. Set theory. Null set theory. They don't have it in there. Empty set theory. The pain is real. They have it in a picture. They don't have it either. Oh, no, they have that weird thing. I don't know. Set on Wikipedia. There we go. Okay. So it's a Scandinavian vowel. Okay. Oh, there's actually a place named after it. That's funny. Huh. That's a cool place name. Null. So yeah, there you go. Copy paste. You find somebody that has a type, copy paste it. Yeah. That's how much fun it is to make quizzes using set theory, because I basically just have there's actually a website that has the terminology on it. I just keep that up and copy and paste things out of it. Okay. So yeah, it's a okay. So like Soren or something like that, I think has the O with a slash through. I actually don't know how to pronounce it, so okay. I think we're good. There we go. Okay. So you guys understand the null meaning? It just means there's nothing in the set. Okay. Okay. All right. So if I have a set A that is, I don't know, aspirin, Tylenol, and Advil, and I have set B that is oxy, Vicodin, fentanyl, and aspirin. And this is, by the way, like set theory, like I said, it comes up a lot, and it comes up a lot in databases. So a very common thing that we do with set theory is ask what elements are in both. Okay, so take a look at A. A is like our inventory. A is our inventory of meds on the first floor of the hospital. B is our inventory of meds on the second floor, like the ICU or whatever. Which meds are in both floors? That's, do you guys understand that? Like, this is the kind of thing that database people do all the time. Like, you work for a car dealership. All right, what cars do both our east side dealership and our west side dealership have? You know? And so look at all the drugs we have on the first floor in set A. Look at all the drugs we have on the second floor in set B, and tell me which drugs appear in both. Okay, and it returns a set. Okay, so make sure you write it with curly braces like Eric did. Okay. Aspirin, Tylenol, Advil, Oxy, Vicodin, fentanyl, aspirin. Which one appears in both? Aspirin. And so what we do is we use the wicket character. Yay, another symbol. So that thing there is called the wicket, and that means intersection. In other words, make a new set that is composed of only the elements that are held in common between A and B. And so the intersection of A and B would be aspirin. Okay. Let's do another one, and let's see if we can have more than one person respond this time. So C is all drugs beginning with an A. Okay. Or you can kind of define a set however you want. With very, very few limitations. Okay. So if the intersection of A and B was aspirin, that's a set containing just the thing. And this, again, this is the kind of thing that database people do all the time. They do set intersection and set union and complement and all of the things that we're learning today. That's their bread and butter. If you ever want to get a job, learn databases. It's not hard. I learned, well, it can be, but the basics can be picked up in a day or so. And you can get a job anywhere in the country. Every company in the world needs a database person if they're beyond a certain size. And you know, they do customer relation management, they do inventory, they do forecasting and all this kind of stuff, sales records, accounts payable, like all this stuff goes into a database. And if you know how to do a database, you're employable. I was on a advisory committee for Fresno Pacific University as they were starting up their computer science program. They invited me to participate on the advisory board for creating it. And they had a bunch of industry people there. And they said the single biggest skill that we need here in the Central Valley are more people that know how to do databases. So take that for what you will. Okay, so we've got here A, aspirin, Tylenol, Advil. C, all drugs in the world ever that begin with an A. So what is A intersect C? Write this in set notation, right? Gotta have curly braces and everything. What is the intersection of A and C? A is aspirin, Tylenol, Advil. C is all drugs in the world that begin with the letter A. And what you're trying to do is find the drugs that appear in both A and C. Aspirin is in there. Aspirin is in there, but that's not the only drug. There are, in fact, multiple drugs in A that begin with A. Maybe I should have called C A. That's going to make a little more sense, right? C is all drugs beginning with the letter A. Okay. Aspirin and Advil. Very good. So A intersect C is aspirin and Advil. Okay. All right. So what is the size of B intersect C? Not aspirin, Advil, etc. Just aspirin and Advil. So David, it's not an infinite set. It's just aspirin and Advil because it has to appear in both A and C. C is quite a large set. There's probably, I don't know, 200 drugs. I don't even know that begin with the letter A. But since those drugs are not in A, they don't appear in your answer. The only drugs that appear in A intersect C are aspirin and Advil because those are in A, they're in C. That's it. Just two. Okay. So what is the size of B intersect C? Again, we got terminology there. We got the absolute value bars. I'm not asking for the set now. And this is something that constantly gets students on quizzes. They're like, but I'm trying to enter aspirin, and it's not taking it because it's only taking numbers. Yeah, because it's an absolute value bar, right? The size of operator, the vertical slashes means I'm asking you for a number. How many elements are in B intersect C? And they're trying to type in, well, the answer is aspirin. No, it's not. It's the size of that. So it's 1, right? The size of B intersect C is 1. Okay. Very good, very good. Yeah. Trying to get the terminology. Yeah. Here, let me help you out there. Here. Copy and paste. There you go. Oh wait, copy that as an image. That's so wild. This is text, but it's literally, it copied it as a PNG. That is so crazy. Huh. Oh, sorry. You can probably do a Unicode search. Let me see. Wicket. No. Intersect. No. Set. I don't know. Unicode has failed me. Okay. So, the intersection of 1, 2, 3, 4 and 3, 4, 5, 6, 7 is 3 and 4, right? You guys see that? So 3 and 4 appear on both of them. So you make a new set with just the things that appear on both sides. Okay? Thank you. Thank you. All right. So when you do intersection, all you do is you search for the elements that appear in both, and that's your answer. Okay. Yeah. And finding those symbols is annoying. Okay. So the size of A is 4, the size of B is 5, the size of the intersection is 2. Right? So I'm just repeating this to try and reemphasize and repeat and reinforce the terminology for set 3. This is not absolute value. It's counting the size. And one interesting thing about intersection is that the size of the intersection is always going to be less than or equal to the size of the original sets, right? It basically has to be smaller. Best case scenario, you have two identical sets, and the size of the intersection is the size of the original set. But intersection is usually smaller, right? Now the opposite of that is union, right? Oh, a couple more rules. If you intersect anything with its complement, you get the empty set, right? Give me everything that is both in a set and not in a set. Okay, nothing. Pretty easy. And the size of the empty set is, of course, null, or 0. The size of the null set is 0. Okay. So union is kind of the opposite of intersect. So union, the difference is give me a set that has people in either set, or both. Okay. Intersect says give me people that are in both sets. It's like the difference between and or. It really is. So intersect is like and, right? Give me something that is in A and B. Union is or. Give me things that are in A or B. Okay? Or both. Both is fine too. So in this case, if you have 1, 2, 3, 4, and 3, 4, 5, 6, 7, then the union is going to be 1, 2, 3, 4, 5, 6, 7. Now you might be like, wait, 3 and 4 appear twice though, right? Like, shouldn't you put 3 and 4 twice into the set? No. And the reason why no, you don't have 3 and 4 twice in the set because something is either in the set or it's not in the set. You can't have 3 in the set twice. It doesn't make any sense, right? You can't have 4 in the set twice. It's just the union of A and B, and the union is the upside down wicket character. It's not a U, it's a upside down wicket. The union of A and B is going to be 1 through 7. Okay. More terminology. Okay. The size of A is 4. The size of B is 5. The size of the union is 7. Union is always going to be greater than or equal to the size of the starting sets, right? So lowest it could be is the size of them if they're identical. Most of the time, though, a union is going to be bigger. Okay, and so if I had A as all Fords at my dealership, and I had B as all McLarens at my dealership, then what is A union B? Again, this ties in very much with databases. You know, hey, give me a set of all my customers that are either in the 30 to 50 age band or bought a car 7 or more years ago. We're going to focus a marketing campaign on them. Very common thing to do. And so you go over to your database guy and you poke him like, hey, I need you to make a list of customers for me that is all people that make more than $100,000, or they bought a car from us more than 7 years ago, or they're in the 30 to 50 age band. And then the database guy grumbles and drinks some coffee and then runs a query that does the set operation, and he hands you a list of emails, and then you go and spam them. Okay? That did not copy properly, Phyllis Center. Yeah. As I said, it's not, it's not technically demanding usually. Most of the stuff you do isn't. Like if you really get into it, there's some pretty wild stuff you can do with databases. But basically you're just doing set theory, and you get paid pretty decent money. When my youth group leader in high school found out that I had some experience with databases, he offered me a job. Like he's like, don't go to college, come work for me for $50,000 a year. And this is in the mid '90s, so $50,000 a year wasn't like terribly much money. back then, but it was pretty good for a high school student, you know. Thank you, thank you. So, what is the union of A and B? See you, Lucian. What? Just type it in English. You don't need any symbols. What is the union of A and B? Got a couple people typing. So A is all of our Fords, B is all of our McLarens in stock. It might be a null set, right? Yeah, it's all Fords and all McLarens. Yeah, so it's the set of all Fords and McLarens at our dealership. Okay. So if you union something with its complement, in this case you get the universe. For our example here, we're talking about integers. The universe is the integers. So if you union something with its complement, you get literally everything in the universe, right? So if I have a set containing just me, the complement is everything in the universe and not me. And so if you union them together, it's me and everything not me. That's literally everything in the universe. Okay? All Fords, all McLarens, yeah. Okay, so the size of that set is infinite. Okay? And we got 5 minutes left in class, but if wanted to blow your mind, there's different sizes of infinities. So not all infinities are the same size. Some infinities are actually bigger than other infinities. Which why? That's a fun talk. That's a really fun talk. There are different sizes of infinities. Yeah. Mm-hmm. And once you start talking about infinity, like all sorts of intuitions that you have just turn out to be wrong, right? It's kind of fun. That's why Buzz always said infinity and beyond. Yeah, he wasn't just talking about Aleph Null, he was going beyond it as well. So that thing here is called Aleph Null. And that's infinity. It's the size of the number of integers, basically. Okay, and then one last bit of terminology is the subset operator. And so subset returns true or false, right? So if you say A subset B, it'll either return true or it'll return false. Is A a subset of B? Okay. And so is A a subset of B? So what that means is every element in A in B? Right? If you've ever seen a Venn diagram before, if A is a subset of B, it'll look like this, right? Every element of A is inside of B. That's what subset means. Okay. In this case, A is not a subset of B. Nope. And in this case, yes. A is a subset of B. Okay? If you've seen Venn diagrams before. And so let me ask you, is A here, is that a subset of B here? A is the numbers 1, 2, 3, 4. B are the numbers 3 through 7. Is it true that every element of A is in B? Yeah, it's false, right? Because there's a couple elements of A that are not in B, so if we drew the Venn diagram, it would look like this, right? So some of the elements of A are in B, 3 and 4 are in B, but some of them are not. So there's overlap, it's not a subset. Subsets have to be fully contained, fully enclosed by the other set for it to be true. Okay. And there's also this thing called a proper subset, which also looks very similar. And it's almost identical to subset, except it also has to be smaller. Because technically B is a subset of itself, right? Because every element in B is in B. But that's usually not how we use the word in English, right? When we say that's a subset of the problem, we're talking about a smaller problem that is enclosed in the bigger problem, right? And so typically when we use English and we say that's a subset of that, we're actually talking about proper subset. A proper subset is a smaller set that is enclosed by a bigger set. All right, so let's stop there. Maybe let's throw up a couple sample quiz questions. We're out of time. If you need to leave, it's fine. I'll just run through a couple sample quiz questions because it's probably going to be helpful. I don't know. Let's see what I can find here. All right. Okay. All right. So we've got a set Bob that contains Jeep, Mustang, Pinto, and Avocado. Set Alice has Jeep, bus, motorcycle, bicycle, and wheelbarrow. So what is yeah. So this is asking what is A intersect B. So what elements of A, this is A over here, go into here, are also in B. This is B over here. So you got Jeep, Mustang, Pinto, and Avocado for A. Jeep, bus, motorcycle, bicycle, wheelbarrow. Which elements in A can also be found in B? It's like a matching game. You gotta go through them carefully. Is Jeep in there? Yeah. Is Mustang in there? No. Is Pinto in there? No. Is Avocado in there? No. Okay, well, that means that's pretty easy then. Then the intersection of the two is just Jeep. Yep. For some reason, my handwriting is a lot better in Word than it is in PowerPoint. I don't know what's going on with that. Okay. Then we got set C here. C is Jeep, bus, Pinto, Avocado, Marshmallow. And so we're asking what is, no, not A, Bob and Charlie. So B intersects C is what? So you go through each of the elements in B and you see if they're in C. So is Jeep in C? Yes, it is. Is bus in C? Yes, it is. Is motorcycle in there? No. Is bicycle in there? Nope. Is wheelbarrow in there? Nope. Okay. So the answer is going to be Jeep and bus. Yep. Isn't it A and C? No, it's Bob. Alice is A. Oh shoot, you're absolutely right. Yeah, no, you're absolutely right. Whatever. Let me change this. So let's make it alphabetical. And then Bob. There you go. It goes A, B, C now. Makes more sense. Okay. Okay. There you go. Problem solved. Just change the problem. Alright, so A and B is Jeep, B and C is Jeep and bus. Okay. And then what VINs are neither Alice or Charlie responsible for? So this is asking for Alice, union, Charlie, complement. Okay. So Alice, union, Charlie. Let's do that one first. So Alice, union, Charlie. You can just sit there and write down all of the VINs that Alice has to start with. Jeep, Mustang, Pinto, Avocado, and then you add everybody that Charlie is responsible for. So union's pretty easy. You just have to make sure not to have duplicates. You just write down everything in A, write down everything in C, and if you ever get a duplicate, like, just delete it. So Jeep is a duplicate, bus, though, is not. Pinto is a duplicate, Avocado is a duplicate, Marshmallow is not. The reason why we don't allow duplicates is because sets don't allow duplicates. So here is A union C. And now we are asking for the complement of it. So all VINs that are not in this. And so Jeep, bus, motorcycle. Okay, so it's going to have motorcycle because motorcycle is not in this, right? Bicycle is not in it. And wheelbarrow. So that is a more complicated set theory thing. So you can combine these things together as much as you want. The intersection of A with the union of B and C, and the complement of that, and then you take the size of that, and all of those things just translate directly into just database queries, right? And you use this, like I said, all the time in math, all the time in logic, law. Yeah. It's set theory is kind of the foundation of modern mathematics, so it's kind of a pretty important topic to get into. But that's it for now. We're already over time. I will throw up some. I'll throw up. I'll throw up a little because of the terminology. I will throw up a quiz in a second, and you can test your set theory knowledge. We'll probably review it again on Friday, and it's the kind of thing that I like putting a lot of questions on the final about. So I'll keep putting up quizzes on it until the percentage of people getting it correct exceeds 80% or so. I always kind of figure about 10% of the class is not paying any attention, not taking any quizzes, not going to lectures, and so I just kind of go, whatever. If I get above 80, then it's probably in about the right place. Okay, so that is it for today. Hope you learned something useful. If you already know set theory, well, sorry, it's probably pretty boring. All right, so peace out. I'll see you guys on Friday.